All right, so now there's two other sort of special angles that you'll need to know about, and they're not like special angles like the angles in the unit circle, but more some terminology that I guess we have to go over. And one of them is a coterminal angle, but before we talk about that, we need to talk about the parts of an angle. So any angle that I measure, if we think about the very specific geometry definition of an angle, it's the measure of the distance between two rays that share a common endpoint, something like that. So this would be the angle that. Now, we're in pre-calculus now, so it's got to be a little bit more specific than that. And the direction of the angle actually is something that we have to take into consideration now. So if we're measuring the angle from, I should draw this all over again, because now we don't really care that they're rays. If I'm measuring from here to here, this is called the initial side, and this is called the terminal side. So the angle starts on the initial side and it ends on the terminal side. So there's this thing called coterminal, and coterminal means it shares the same initial side and the terminal side. Well, you might be thinking, well, how could the angles be different? Well, let's say that this is a pi/6 angle. Well, what I could do, instead of just going straight from the initial side to the terminal side, I could actually pass it and measure all the way around that big. Well, that is going to be, we know from here to here, all the way around the circle, is going to be 2 pi plus pi/6. So that should be 12 pi/6 plus pi/6 should be 13 pi/6 altogether. So 13 pi/6 and pi/6 have the exact same sine, cosine, tangent, secant, cosecant, cotangent, everything. They are what we call coterminal angles because they share a terminal side and an initial side. Now you can find there are actually an infinite number of coterminal angles for any given angle, because all I have to do is keep adding or subtracting 2 pi. Well, now that also raises another question. Negative angles. Well, another thing that I could do is actually measure backwards from the initial side to the terminal side. And that angle would be 2 pi minus pi/6, which would be 12 pi, 11 pi/6. But we must be specific, like all mathematicians, and we're actually measuring in the opposite direction. So this would be negative 11 pi/6. I drew this in a pretty convenient way. There are things as angles drawn in standard position, and angles drawn in standard position have their initial side on the positive x-axis. So if I have a coordinate system and I have an angle right there, that's an angle drawn in standard position. I could draw the exact same angle on the other side, but that's not in standard position, because this initial side is not on the positive x-axis. Furthermore, this could be not in standard position if this side is the initial side. But if this side is the initial side and I measure up to the terminal side, that is in standard position. So I can also measure down to a terminal side, but this would be a negative angle. Maybe that's theta, and this is negative theta. So if the initial side is on the positive x-axis and you're measuring in a counterclockwise direction, that is an angle in standard position. It could still be in standard position if you measure clockwise, but it would be a negative angle. So, I mean, if we talk about pi/6, pi/6 is coterminal with a negative 11 pi/6, 13 pi/6. All I could do to get like an infinite number more, if I have 13 pi/6 plus 2 pi, would give me 25 pi over 6. That's coterminal. I could add 12 pi over 6 again and get 37 pi over 6. I could get 49 pi over 6. Those are all coterminal angles with pi over 6. As far as negative angles are concerned, I could subtract another 12 pi over 6 from 11 pi over 6, and let's see if I can do this. Negative 23 pi over 6. I could get negative 35 pi over 6. I could get negative 47 pi over 6. And those are also all coterminal angles with pi over 6. So either adding or subtracting 2 pi would get you coterminal angles with whatever your given angle is. If you're working with degrees, which, yeah, why not? It could happen. You just add or subtract 360. That's it. Because this whole circle is 2 pi. The whole circle is also 360 degrees. So it kind of works both ways. Another thing that we want to talk about, well, I want to talk about, you might not, but I do, are reference angles. And a reference angle is the smallest angle that shares a terminal side and the x-axis. So the easiest way to show you this is if I have this angle and maybe that's like maybe 157. I don't know. Something like that. Maybe that's what it is, maybe that's what it isn't. Whatever. The reference angle is going to be this angle right here. A reference angle will always be acute and it will always be positive. So how would I figure that out? Well, I know this whole thing is 180. So if I would just take 180 minus 157, and I can't do that in my head, that should be a 3, that's a 2, no, that's a 7 minus 5 is 2. This would be 23 degrees. And it's positive. Direction doesn't matter, it's just a reference angle. If I had this angle in standard position, and maybe this angle was 47 degrees, the reference angle is also 47 degrees. If I had maybe this angle in standard position, where the whole thing was, let's make it 226. The reference angle would be this thing, and I would take 226 minus 180 to get 622 minus 18 is 46. So this is 46 degrees. There you go. That's it. So whether you do 180 minus the angle or the angle minus 180, just use some thinking about that. The same thing would work if you were dealing with radians. Maybe if we have, let's just take some more common denominator stuff. I have this angle in standard position, and maybe it's going to be, let's say, 3, well, how about 7 pi over 10? Something like that. Not directly on the unit circle, but why not? 7 pi over 10 is a radian measure. So I would take pi minus 7 pi over 10, which is 10 pi over 10 minus 7 pi over 10, which is 3 pi over 10. So this reference angle is 3 pi over 10. And I probably did that the complicated way, but that's the way my brain initially thought about it, so I went with it. But yeah, that's reference angles. No big deal.